Welcome back. Lecture 9 will cover the existing integrated land use transportation models which are already in use in different urban planning areas. The different concepts that would be covered are early land use transportation models, Lowry's model of metropolis, which we have also covered earlier, the theory part was done, and urban simulation models which are currently in use. And we will also detail out three urban simulation models, which these are ITLOOP, MUSA, and UrbanSim. So when we talk about land use transport interaction, the concept of interrelationship between transport and spatial development was initiated or rather taken up during the 1950s in USA. And the first model that came into being was the accessibility model by Hansen. And this model was a basic model which talked about which stated that locations with good accessibility had a higher chance of being developed and at higher density. And this model was applied in the Washington DC area, and this was the first model which actually talked about how transportation is related with land use, and transportation was taken in form of accessibility to different land areas. Then came the intervening opportunities model by Lathrop in 1965, and where the opportunity for an activity was determined based on the land area and intensity of land use, and it was highest at the point of maximum access. That means the opportunity was highest where access was high. Then finite probability of the trip maker to stop at any possible alternative opportunity. That's why it was called the intervening opportunities model. That means a person has got based on the different criteria, one area of course has got the highest accessibility, but along the way there could be other opportunities, and based on a probability a person may choose an area which comes along the way. So this was called the intervening opportunity. So the choice is not only the one with the highest, but it could be the one which would be in a lower order of choice as well. So then came the empiric model, which was made by Hill, and this was applied in the Boston Regional Planning Project. And here the population and employment is exogenously determined, and it's allocated in zones considering the existing levels of service of public services, transportation networks, and transitions of local activities. That means how local activities had been changing. So that means again exogenous input, exogenous projections of population and employment is taken and then allocated as per the potential of different areas. And while they were considering potential along with transportation, they also considered other factors as well, which includes public services and transitions within that of local activities within that area and so on. Then the Lowry's model of metropolis came. As you know, this is the most famous land use transportation model and is still applied in many areas, and modifications of this particular model, there has been various modifications, and modifications of these models are currently applied in many developed countries as well. And this is the basic modeling, this is the initial model which started the process of land use transportation modeling. And this model incorporates the land use transport feedback cycle. Two singly constrained spatial interaction location models were introduced in this particular model. And as we have discussed earlier, the residential location model, and then there was a service and retail employment location model. So the first model determined residential location based on location of the different industries or jobs, you can say. For example, Tij is equal to walkthroughs between residential zone I and work zone J. Ej is the workers in J, that is the the exogenous input of jobs at different locations is already there, and then Ri is the dwelling in I, and Cij is the travel time between I and J. So this particular equation has to be iterated and balanced to get to the estimates of Ri, and that actually shows us for particular location of jobs what could be the spread of residences in an urban area. And similarly, the second model, as we discussed earlier, is linked with whenever there is a number of residences. For example, in iteration 1, first the work trips to the workplace of basic industries was determined, and in the next we did two assumptions. One is, for each job there is a certain number of people who are supported, and using this model we found out where these people are going to reside, and then we also determined that retail employees supported by one resident. And once we know that, so then we did a service and retail employment location model. This model actually helped in determining the number of shopping trips, SIJ, where shopping trips between residential zone I to retail facilities in zone J, and PIJ is the population in I to be distributed, and WJ is the shopping facilities in J. So that means once we know that so many residences are allocated, then for that there are certain number of retail employees or jobs or retail jobs that are there, and retail jobs require people again. So that was determined through this, and then both Sij and Tij values could give us also transport estimate. So both transport estimate as well as location estimates were also determined using these two equations. So that is the beauty of the model, because it was integrating both land use and transportation component. So if I look into the urban land use transportation models currently in use, so the most widely used successor of the Lowry model is the disaggregate residential allocation model called DRAM, and employment allocation model MPAL, and this together is called it's present in a model system which is ITLOOP, and this was developed by Putman and colleagues in 1983. And a variation of this model, or rather following the same lines of the Lowry model, TRANUS and EMIPLAN are two model systems which are developed by De La Barra for TRANUS and ECNIC for EMIPLAN, and this used both the interregional input-output method, which was again exogenous input and output that needs to be determined, and that also input that was taken in, and that actually was used to determine the amount of flow. And these two models were particularly used in Europe, following the similar principles of spatial allocation. So these are the two models. And then there was Musa, which used the bid rent process in the modeling, and then there were other models as well. Out of that, this urban SIM, and we already discussed California urban futures model in the last lecture, and then we also have urban SIM, which is one of the latest models which is in use and which employs multi-agent and micro simulation model, and this is a very, very advanced model which we will discuss in the subsequent part of the lecture, in the next part of the lecture. So the current research in land use transportation interaction has been able to successfully combine entropy maximization and locational accessibility, which are the basis of spatial interaction theory, and with the economic notions of utility maximization. So entropy maximization is the spatial interaction theory, is arising from spatial interaction theory, whereas locational accessibility is also part from spatial interaction theory, and this is also combined with the discrete choice or utility maximization part, and this actually helps in developing very robust choice models or models which will help us to determine land use for an urban area. So in the model, the ITLOOP model system, as we were discussing, it has got different components, and the full form is Integrated Transportation and Land Use Package. It was made in 1971, but it has been developed after that, and it includes both the location and transportation models. There are more or less 5 parts to it. The first part is MPAL, which is employment location. It predicts the employment location for every 5-year periods, and it predicts it based on the access cost of population, and it also does it for different income groups and for every zone that is being there in the particular planning area. So this is the MPAL model. So this is the land use part. And similarly, DRAM model, it includes one component of land use, which is the household location, and also the trip distribution and trip generation part. So this is where the the transportation part and the location part is getting combined. And modified version of the singly constrained, this is a modified version of the singly constrained spatial interaction model. So it's similar to the Lowry model to some extent, and allocation depends on attractiveness and access cost to employment of different household types. That means for each household type, the attractiveness and access, these two vary. So that means there is a utility, utility part that is also there for each suitability part that is being considered, and that is actually used for allocation. And then we have got LANCON. This component estimates the land consumption part. Then MS split, M split, which is strip matrices are split into, this is the mode choice part. With their multinomial logit formulations are used. This we will explain in later lectures, what is multinomial logit and all. This is used to determine what should be the mode choices of the people who are traveling. And then comes the network part, net WK. This part is strips are assigned to capacity constrained highway network. So this is called the assignment part. So the 4 stages of trip generation, distribution, modal split as well as network assignment is taken care of along with household location and employment location, which completes the entire land use transportation modeling package. Similar to this particular model, we also have got the EMIPLAN model. Some changes are there. It uses input-output model to predict the changes in demand for space. Then demand is allocated to spatial zones using the concept of random utility. An equilibrium model is derived by solving all the equations subjected to constraints. Then there is a transport model which predicts modal split and assignment using the random utility model. And of course, there is the feedback loop. That means cost, travel time, etc. due to congestion in the land use model is again brought back into the land use model to determine the accessibility, which actually determines the allocation part as well. So this is the EMIPLAN model. And in TRANUS, almost similar, but some changes again. Social, economic, financial and environmental impacts of transport policies could be evaluated using the TRANUS model, which was not there in the EMIPLAN model to that extent. And the land use activity model is there along with the transport model, both are present. So these are the 2 model systems used mostly in Europe. Then we have got MUSA and Urban, where the bid function is actually being incorporated. I will explain that. And spatial allocation of land use is handled using this particular bid function. And finally, we have got UrbanSim, which will be also covered in the later slides. So MUSA is the land use transportation model, but it's actually the land use part, and the transportation part either could be some other software which is actually used with this particular model. And right now it is found in the Cube software. It is also called CubeLand. So Cube is a very popular software for transportation planning and modeling. So CubeLand is the component which takes care of land use in the CubeLand model, in the Cube software package. So MUSA is the one, is the basic model system which is used in this particular software package. So MUSA, this is the land use model. It was initially combined with STRANUS. It was made by Martinez and it was made for Chile, Santiago. So the model system, transportation model system, was known as STRANUS and STRAUS, and this was a 4-stage model system, but currently this model could be also combined with TRANUS as well. So TRANUS also can support this kind of combination along with MUSA, and that gives us an integrated land use transportation model. So MUSA talks about location of activities, both households and farms, and it uses bid rent, where bid rent theory is utilized to determine this location, allocation of households and farms in an urban area. And as you can understand, so this land rents are endogenous to the model. So we determine the land rents, and based on that we determine where different choices would be allocated. And we considered equilibrium conditions, and we also consider land availability and developers' behavior inside this model, which says that with particular available lands, developers can build, and based on the bid choices and all, and that actually helps us in allocating the different uses. And total population and farm forecast is coming from exogenous input, and it comes from the regional input-output model, and this has got a GIS interface to it. The location choices are for household clusters, zones, dwelling types, farm types, and each one of these are allocated to different lot sizes. That means The location choice is for different location at different lots, and it is location at lots is as per either for residences as per dwelling type, or it could be as per the household cluster, which means a type of household, and each type of household could be allocated to a particular zone or to a particular dwelling type. According to that, it will get some choices, and it could be allocated in the most suitable choice, and using a disaggregated behavioral model. And farm types also could choose similarly using a disaggregated behavioral model, and it could be allocated a particular lot, and that is the level of disaggregation this model allows. And if you can see on the on this side, we see that we have a basic transport model, which is the mobility part is over here: trip generation, destination, mode choice, and route choice. But this is connected with land use and rent. This is the new thing that is different from the previous earlier models. So rents are part, or the amount of land use is determined based on rents. So we take exogenous input from outside, a population and number of jobs and farms, and using that we can determine endogenously the rent and the developer's choice to be developers choices, and then actually we can determine the land use for a particular area. So this also has role to play. So spatial location and accessibility, these are two criteria which are also going back and forth between the choice models. So in the choice model and the transportation model, this is how these two are linked. Then comes the UrbanSim model by Paul Weddell in 2002. This was the model system that came into being, and this is the very advanced model. And it is, we can call it, instead of a land use transportation model, we can call it into a land use transportation interaction simulation system, or an urban simulation system, because it has got several components, and the entire urban land use and growth changes and along with transportation could be modeled in this particular, or rather simulated in this particular model. And it includes several land use components which are called as individual agents, and both demand and supply of real estate and their prices is endogenous to the model. That means not only the demand for real estate, that is how many some residents are choosing to locate somewhere, or some farms are choosing to locate somewhere. This is the demand part. Supply part is where are the developers willing to build, which are the kinds of development they are willing to build where, along with choice of a farm to move from one area to another, which leads to this particular demand. These are also different components of the model that are being that is also endogenously modeled in this particular modeling system. And it is definitely it's a dynamic model which with updates at every 1 year period. That means inputs at the end of 1 year period, outputs at the end of 1 year period becomes the input for the next iteration. And there is a time lag between development decision and property availability. That means developer decides to build at a particular location based on different criteria, based on the market demand, based on available land price, and so on. And the property eventually becomes available at the end of a certain time period. So that is also captured in this particular model, and this leads to we can say that sort of disequilibrium in real estate market, along with changes in rent, prices, and vacancy rates. These are also modeled in the process. So that means all these variables, rents, prices, vacancy rates, these are all there, so that whenever a person chooses a particular lot, he considers the current rent, the current prices, the current vacancy rates, and accordingly he can choose a particular area for moving in. So this model is also sensitive to different lots and lots of policies like urban growth boundaries, and then it talks about high density development. Different kinds of policies could be undertaken using this model. It also allows manual input, like for example, there is a certain change in certain laws in a certain area, or certain policies needs to be tested. This kind of manual input can be also put inside the model. And discrete choice models are used for determining choice, but the framework that is used is of course the random utility maximization framework, which we will explain in subsequent lectures. But this is random utility theory, and this is where an individual decides based on the probabilities of different choice alternatives. So if I look into the model structure, we have the exogenous models, which is the macroeconomic model, which which gives us forecasts for population and employment, it's sector-wise employment for different sectors, for different job types. And then we have the travel demand model, which is also exogenous. That means whatever output comes out of the land use components, it goes as input to the travel demand model, and it gives the feedback of travel times between different destinations or different different origin and destinations, and also the travel utilities between those destinations. So these are the two feedbacks that goes back and forth in between these two models. And the different endogenous model systems are the accessibility model, economic and demographic transition models, household and employment mobility models. Also intra-urban relocation is also there. That means if you want to change from one zone to another within the urban area, that is also possible. Then household and employment location choice models, real estate development model, and land price model. So all these models should be explained in the next lecture in detail. But at the same time, I would like to say these are different model components. This could be individually modeled, but as you can understand, each is linked with each other through several variables or several parameters. For example, land price model is definitely, it depends on several attributes, but the land price itself influences real estate development, or real estate development influences the household and employment location choices. So all these model systems are linked. And if you can see in the figure provided over here, this shows the process flow of UrbanSim. So how the data from one model moves to another, which model is connected with which model. As you can see in the beginning, you can see that, okay, there are external models over here. These are the travel demand model system and the macroeconomic model system. From here, travel demand results in travel model outputs, using which we can determine accessibility. So accessibility model is over here. It takes input from the travel demand model. At the same time, there could be certain other things like the macroeconomic model, which actually talks about the total population or the employment that is going to come to this new area, or rather which would be the forecast for this particular area. That actually could also influence the accessibility model, and so on. So this is how these two are linked. And we have a term called control totals. Again, we will explain it that later. What it means is dividing the entire population into different socioeconomic groups and then matching the totals so that it matches with the overall economic forecast. So that is why it is called a control total. So that is basically a check procedure. So once we have this, so accessibility model leads to economic and demographic transition models. So this model actually shows how the different jobs and the demographic distribution changes in different areas. And then we have the residential and employment mobility models. This takes in input again from other models, and this actually determines that which of the residences and which of the jobs will change their location. That means some family may decide to shift from one part of the city to another part of the city. Same goes for jobs. And then residents and all the people who are changing jobs, they are, as soon as they do that, then some of the locations where they were residing or some of the buildings where these offices were there, those becomes empty and available in the market. So that goes into the real estate vacancies. Then there are also unplaced jobs and households, like a household is not yet allocated in a certain area. Then they get allocated using a residential location choice model. And then there is a real estate development model which also works parallelly, and then there is the land price model. So see, all the models are linked in a framework, and we need to determine which has to be called in what sequence. That is done through the software architecture of this particular model, which would be discussed in subsequent chapters. But all these models are linked together and they give feedback to each other, and they form an overall modeling system or a simulation system for the entire urban area. So if I compare the different models, for example, we in this particular chart, we have compared DRAM, MPAL with EMIPLAN TRANUS, with California Urban Futures and UrbanSim. So if you see the model structure, see both California Urban Futures and UrbanSim follows discrete choice, Whereas MEPlan and DRAM-MPAL, this follows spatial allocation models. So this follows the spatial allocation theory, whereas this follows the discrete choice theory, or which is an economic theory. Then household location choice is modeled in all the models except for the California Urban Futures. So this part is not there. Then household classification, as you can see, here around 8 categories of housing is considered, whereas over here it's disaggregate. It varies as per income level, person, worker, child. So it's because it's a micro simulation model. We can have different combinations of characteristics to determine a particular household. And then we have got employment location choice, which is modeled in most of the models except in this California Urban Futures. And then employment classification, again there are in the urban sim model there are around 10 to 20 sectors, whereas in the other models it is we have 8 sectors over in DRAM-MPAL. Then real estate development is not modeled in this one in the DRAM-MPAL or ITLOOP, and then this one is modeled in the MEPlan and also modeled in the California Urban Futures, as we are discussing, like developable lands which are at different and we create a list of developable lands and create a list of which are the most profitable lands and accordingly allocate development. So that's why this part is modeled. Real estate classification, here we can see there in urban sim there are 24 developments like commercial development of different kinds, residential developments of different kind, and so on, whereas in other cases it is taken as a land use, 4 categories of land use, or over here like 7 categories of land use. In real estate measures we have got acres, whereas in urban sim it is both acres and unit floor space. Both is so it's not only land use, it's also building space, both are considered. Real estate prices are not modeled in all of them except for urban sim, so land price model is there. Geographic basis, if you remember the discussion on macro and micro, these are the initial models are based on zones or census tracts, whereas the later on models are based on grids. Temporal basis, this urban sim is annual. We can call it a dynamic disequilibrium model, whereas the other models are equilibrium, or this is equilibrium of 5 to 10 years and so on. Interaction with travel model, all the models are connected except for urban futures model. It is a pure land use model. Then model structure is partial, and whereas this is a full model structure, incorporates all the different components for urban simulation. And then the software access, whereas these are proprietary, these are softwares you need to buy, whereas this is urban sim is an open source software you can directly use. So these are the references you can follow for this lecture, and in conclusion we can say land use transportation modeling evolved from simple transport accessibility based models to urban simulation systems incorporating various submodels. Land use submodels included in the land use transportation modeling initially included only the real estate demand side models such as residential and farm location choice, but later models like urban sim included the supply side models as well, like real estate development models, land price models, and so on. Discrete choice models using random utility maximization to determine choice behavior is also being increasingly used in the land use transportation model systems currently in use. Thank you.